Hello and Assalamualaikum. My name is Muhammad Aiman Syazwi bin SUBOH. My metric number is J19A0171. And in this video, my group, which is group I, will present about the fabrication of PVA plus glycerol and PVA plus glycerol plus CNC. First thing first, membrane is a thin layer of semi-permeable material that is employed for solute separation. Polyvinyl alcohol, or PVA, is a synthetic polymer that is soluble in water. Its solubility in water is regulated by hydrolysis, molecular weight and distribution, particle size distribution, and crystallinity. Glycerol, on the other hand, is a plasticizer that improves flow and flexibility, toughness, impact resistance, and braking during packing and transportation. Cellulose nanocrystal, or CNCs, is an additive filler that exhibit unique features such as low density, high aspect ratio, high mechanical strength, and high specific surface area. In this experiment, we prepared two samples of membrane. The first one is a mixture of PVA and glycerol. The second one is PVA plus glycerol plus CNC. There are a few tests that will be conducted in this experiment. The first being optical microscope, OM. The second is scanning electron microscope, SEM. The third is Fourier transform infrared, FTIR, and the last one are tensile tests. This test is conducted to compare the properties of the membrane.
The application of nanofiltration membranes presents a number of challenges, including layer porousness, selectivity, and film fouling. Multifunctional layers with increased anti-fouling, antimicrobial, water permeability, salt selectivity, and water permeability are required to solve these concerns. These layers must also have improved salt selectivity in order to create a thin film that is successful in a number of areas. We make use of the CNC. CNC layers offer exceptional qualities as a result of the nanoparticles that make up their construction. These nanoparticles are hydrophilic, inexpensive, natural, and biodegradable.
The objective of this experiment is to develop a thin membrane film using synthetic polymer. Second is to characterize the thin membrane film using optical microscope, OM, tensile test, scanning electron microscope, SEM, and Fourier transform infrared, FTIR test.
For the methodology, we prepare 4 samples of thin film membranes. First 2 samples of PVA with CNC and glycerol, and the next 2 samples with glycerol and PVA. These samples were prepared by using phase inversion technique, which is precipitation by solvent evaporation, or known as solvent casting. In this experiment, we use scanning electron microscope, SEM, Fourier transform infrared spectroscopy, FTIR, optical microscopy, OM, and universal testing machine to analyze the membrane samples.
For result discussion, I will explain for optical microscope, which is OM, and scanning electron microscope, which is SEM. For OM, based on the result that has been gained from OM, the surface is smooth and glycerol is distributed uniformly in the mixed film. In this experiment, we were using only 5% of glycerol. If there is a further rise in glycerol concentration, this can generate agglomeration and further results in voids. In figure 2 that shows sample 2 with the addition of CNC, there are obvious aggregation which can affect tensile strength that my friends will explain more on tensile strength results. Next, SEM. The surface and cross-section were observed by using SEM. Usually, pure PVA membrane was plain. From this result, it shows that glycerol and PVA are compatible with each other. Just like in OM, the surface become rougher with the addition of CNC because of the aggregation. With CNC, a multiple number of aggregates were seen on the membrane surface. With low CNC concentration, SEM was able to show a homogeneous distribution of CNC within PVA matrix.
The mechanical characteristics of polymeric membranes are one of the factors that are considered to be among the most essential. The membranes based on the PVA that were produced were put through tensile testing so that the level of their mechanical strength could be determined. According to what is shown in the table, the mechanical qualities improve from sample 1 to sample 2 for the membranes that contain PVA and glycerol in the first sample and membranes that contain PVA, glycerol, and CNC in the second sample. Because of this change in direction, the tensile strength of the membranes was improved by the incorporation of CNC as a filler into the aqueous solution of PVA and glycerol. The remarkable improvement in the mechanical properties of these composites was attributed to the CNC's intrinsic high strength and modulus, as well as a strong hydrogen bonding between the cellulose molecule and the PVA matrix. In other words, the improvement was caused by the combinations of these two factors. According to the findings of the study, the mechanical strength of the membrane was significantly increased by the attaching of its functional group to one another in a cross-linking pattern. Understanding the significance of FTIR spectrum is the most important insight that can be gained from the FTIR spectroscopy investigation. The spectrum can provide information such as absorption versus wave number or transmission versus wave number. Our experimental inquiry will focus on the analysis of the relationship between absorber and wave number. The graphs that follow display the mid-IR spectra of PVA combined with glycerol and PVA combined with glycerol and CNC. The absorbance in plot is plotted on the y-axis and the wave number are shown in the reciprocal centimeters. The fact that there are more than 5 peaks of absorption demonstrates that the substances that were put through the ringer during the course of our research are not basic or simple chemicals. The label for the graph describes a single bond region that ranges from 2500 to 4000. In these regions, the presence of a hydrogen bond in the chemicals are being examined can be identified by the appearance of a significant absorption band. Oxygen-related bonding in the samples is demonstrated by the presence of sharp bonds at 3262.35 in the figure 4 and 3277.05 in figure 5. Because the samples that were tested did not exhibit any additional absorption peaks near the wavelengths of 3000 to 3200, it can be deduced that they did not contain any aromatic chemicals. In addition to that, there were no more absorption peaks around the wavelengths of 2700 to 2800. This could be the evidence that the aldehyde was not present in the samples that were analyzed. Because there is no triple bond area between 2000 and 2500, there is no possibility of a C-double bond existing in the samples that were analyzed. There was no evidence of C-double bonding in the samples based on the observations that there were no substantial absorption peaks at 1600. It was discovered that there were primary aliphatic alcohols, inorganic phosphates, aliphatic primary amides, and aliphatic hydrocarbons.
So now we have come to the conclusion of this mini project. 2 types of PVA glycerol membranes have been successfully formulated in the end of the experiment through solvent casting method, which one of them with the presence of CNC as a filler. In visual observation, we can conclude that both samples are transparent, while membrane samples with the presence of CNC have more air bubbles trapped inside. While from the results of the characterization test, there are also a few conclusions that can be made. First, the incorporation of CNC in the PVA glycerol membrane improves the membrane mechanical properties. Further, by comparing FTIR analysis results of both samples, membrane with the addition of CNC show a sharper absorption peak, indicating the addition of CNC improved the number of bonds responsible to the absorption. Meanwhile, through observation under OM and SEM, it can be concluded that the addition of CNC will increase the porosity and surface roughness of the membrane. Overall, the results of the experiment confirm the ability of CNC as filler or additives in enhancing the mechanical properties of a membrane. So that's all from me. Thank you.